This is the video for lesson 9.1, and for this lesson I'd like you to copy down the learning target. The learning target is I can use vectors and translation rules to translate figures. So in this video you're going to learn about vectors and translation rules and how to translate a figure from one point on the coordinate plane to another point. The other vocabulary that I'd like you to copy down is an image. Okay, an image is a new figure that is produced from the transformation of another figure. Transformation just means that we're going to move it in some way. Okay, we're going to learn about other transformations in the next couple of lessons, but today we're going to specifically talk about translating. Okay, so translation is one form of transformation. The pre-image is the original figure that you have, and then you're going to make another image, which we call the image. So the pre-image is the original figure. The image is the new figure once you have it in a new location on the coordinate plane. Definition of isometry. Isometry is a transformation that preserves the size and shape of the original figure. So we're not making it bigger or smaller. We're keeping it the same size and the same shape. We're simply moving it to somewhere else based on either a vector or a translation rule. Before we go any further, I'd just like to remind you that throughout the video, if you have any questions, please use the spaces on your paper to write those questions down. And before we go any further, I'd like to remind you that you should be doing these notes in pencil, just in case you make an error. So please use a pencil on all work done for geometry, and just remember that if there are any questions, you're going to write those down and be able to ask those questions in class. So on this screen we see that we have a translation theorem, and that theorem says a translation is an isometry that slides a figure up, down, right, or left. So translation is literally just moving the figure a certain number of spaces in one of those directions. A vector, and you'll see a vector right down here, it's basically just an arrow drawn from one point to another, and basically it says that it has both direction, so we know which direction to move our figure, and magnitude, which means the number of spaces. So not only do we know to move it right, but we know how many units to move it right. Okay, so we represent this vector, this direction and magnitude component. It tells us where to move the figure and how many units to move it by using this little arrow here. So the arrow has an initial point, that's the starting point of the vector here at F. Notice that it has a dot there. And the terminal point is where the end of the vector is. So notice that there's an arrow where we see the terminal point. So over here, this is the terminal point. Because it's an arrow, that's where it ends. And this point F is the initial point. So these terms are things that you're going to want to be familiar with. So if I ask you what is the initial point or what is the terminal point, you should be able to point that out to me. And those points just give direction to the arrow, but then down here you can see that the number of units is also pointed out. So how far did we have to go over before we had to go up? That's one thing that you want to note. So the horizontal piece is left to right. The vertical part of the vector is up or down. Okay, so we need to know that because the next term that comes up here is component form. Component form looks like this. It has some different brackets, doesn't have the parentheses like an ordered pair does, but the horizontal number of units goes first and the vertical number of units goes second. Okay, so the component form is this. So if I was to write the component form for the vector that's shown in this diagram, I would have 5 for the horizontal component. Notice that it says 5 units to the right, and I would have 3 units in the vertical space because we're going up 3 units. Now anytime we go down, we're going to have a negative value for our vertical part of the component form, and if we go left, we are going to have a negative for the horizontal. So just keep in mind that sometimes these numbers will be negative based on which direction they'd like us to move the figure. Let's take a look at example number 1. In this example, they're asking us to use a translation rule, which really is saying the same thing as what a vector says. We didn't have a translation rule in the vocabulary section, but I do want to introduce it here in example 1. So we are going to translate a figure in a coordinate plane, and to begin, what we need to do is we need to plot these 4 points. So if you need to stop the video and plot those 4 points, please do that now. And once you have those 4 points plotted, we're going to connect them and create this quadrilateral. All right, so now we have our original image. So that's what we just call the pre-image. The original figure is the pre-image. And then in our directions, always remember that you want to read the directions, find the image of each vertex after the translation. So if you take a look, points A, B, C, and D are listed here. And then we have our translation rule. For every x value, I'd like you to add 4. For every y value, I'd like you to subtract 3. So for our next 4 points that we plot, they're going to be called the image, and we are going to note that they are the image points by putting this little apostrophe next to the letter. Okay, so if you see that little apostrophe, you know that's the image, where the ones that don't have the apostrophe are the pre-image points. They're the original points. All right, let's go ahead and make the new point. So I have to add 4 to negative 3. Negative 3 plus 4 is positive 1. Then I have to add 4 to this negative 3 here, which is also just going to be 1. Add 4 to this 2, which is going to be 6. Add 4 to this 2 down here, which is also going to be 6. So then we have to do our y values. Negative 3, we have to subtract 3 from every y value. Here I have negative 1. Negative 3 subtracted from 5, just 5 minus 3 is 2. 6 minus 3 is 3. And 2 minus 3 is negative 1. Those 4 points now need to be plotted on your coordinate plane, and then we are going to just make sure that we have actually translated the figure according to the translation rule. And you can see there that I've plotted those image points, and just recall that we were supposed to be moving the entire original image to the right 4 and down 3. So did we do that? Let's just check one point. If we start at the point that we labeled C, did we go over to the right 4 and did we go down 3 when we plotted our C prime? Yes, we did. So you should be able to check that with all 4 points and see that that translation rule actually worked. Okay, we're on the back side of your paper now with example number 2. I'd like you to write a rule for a translation. So if you can see, right down here I have a space sort of selected where I'm going to write my translation rule, and before I write it, I'm going to write in my ordered pairs for both the solid line figure over to the right, so the original figure, which is A, B, C. That's my original figure, so I'm going to look at the graph and write down the ordered pairs for each one. So I just want to point out before we start that each one of these units is 2. So this is a 4, this is a 6, and in between there is going to be the odd numbers. So we want to make sure that we don't write down a wrong number for our ordered pairs. So I'm going to go ahead and do that right now. And I'd also want to do that for the image points, so A prime, B prime, C prime, the one that is hyphenated, the figure that's hyphenated on our graph here. I want to write down the ordered pairs for those points as well. And now that I have all the ordered pairs here, I'm going to start by comparing the x values. So this x value from our original image and the new image, what's the distance that I've moved that and which direction have I gone? Looks to me like I've added 3 for my x's. And I want to compare that for point B and B prime. I also added 3. And from C to C prime, I also added 3. So it looks like the rule for the x's is going to be x plus 3. Everything gets slid over 3 units from the original point. And now I'm going to do the same thing, but I'm going to do it with my y values. So what happened from point A, where y was 7, to point A prime, where y is now 5? Well, it looks like we subtracted 2. Let's just make sure we did that with B as well. 3 was the value for y in B. 1 is the value for y in B prime. So again, we subtracted 2. And finally, for point C, the y value was 3 originally, and now it is 1. So that means that we did move y down 2 there. So our translation rule should be y minus 2 because the entire image got moved down 2 units. Example number 3 asks us to identify vector components. So a vector, remember, is that arrow that shows up on the coordinate plane. We do need to give it a name and we need to write its component form. Okay, so that's what I have written here. So go ahead and fill that part in. And I want you to notice that on the vector we have an arrow here. Remember, that's called the terminal point. So that letter is going to go second in the naming of the vector. So we have a B as the second point. This is actually the initial point, does not have an arrow, and so that's going to go first in terms of its name. So we have vector AB, but there is a special symbol that I want to include here. The special symbol is simply a partial arrow. Notice that I did not put that last tail on the arrowhead. It's just simply this. Okay, so make sure that you include the symbol, otherwise we will possibly not know that it is a vector. It could be a line, it could be a line segment if you don't include that little symbol at the top. So how many units did we have to go horizontal, which means right to left, and how many units did we have to go in a vertical direction? So let's start at that initial point. Okay, how are we going to end up over here at B? Well, let's see where those two intersect. This is kind of the point where the horizontal and vertical turn or meet if we count the number of units. And let's go ahead and count those units. From A, we have 1, 2, 3, 4, 5. So we're going 5 in the vertical direction, but we are going 1, 2, 3, 4, 5, 6, 7 in the horizontal direction. Okay, so we are going down, so we have to include that as a negative 5. And we are going to the right, so that's going to be positive. So just remember, this is my horizontal. That's going to go first in my component form. And because I'm going down, I have to say that that is negative 5 for the vertical direction and distance. So remember, a component form shows magnitude and it shows direction. So that negative sign is super important because we're going down. Okay, one last example for this video. I just want to make sure that you know how to use the component form of a vector. I'm going to go ahead and plot these points of a triangle and label them. Go ahead and stop the video if you need to, and then we'll talk about how to translate those 3 points using the vector that is shown right here. Now, once you have the 3 points plotted, like I do here on my coordinate plane, and I have them labeled, I'm going to refer to the vector or component form that I have 3, negative 4, so that I know how many units to move this figure. So I have my pre-image in red, and I'm going to make my image in purple. I have to go to the right 3, and I'm going to go down 4 because that has a negative. Okay, and I have to do this for each and every point. So I want to count from every point. I'm going to start with point B because it's easiest to look at on this video. But 1, 2, 3 is where I'm going to go down now. 1, 2, 3, 4. So point B prime is going to be located right here because I went to the right 3 and I went down 4. So we should do that for each point. Go ahead and stop the video if you need to and make the new points B prime, A prime, and C prime. One last thing I want to point out is that the shape and the size did not change when we translated the figure. So the triangle didn't get any bigger, it didn't change shape at all, and we just basically translated it or moved it or slid it over to the right 3 units and down 4 units. So again, this is an isometry, which means that we didn't change size or shape. If there are questions, you can be sure to ask those in class, and we will have some practice problems to complete once I see that you've done your notes. Thanks for watching.